important notes about online learning. Download the slides and go through them along with the video or audio. You still need to make notes and try and express things in your own words, and this is going to be important to develop your own understanding. You still need to go through your manual and do all the work points. You still need to explore further through additional reading, online investigation, etc. For example, YouTube has some wonderful linguistic resources. While doing online learning, it becomes even more important that you do these things. You will need to manage your own time and take responsibility for your own learning. During the course so far, we've been talking about grammar. We've mentioned the word universal grammar a couple of times, and I'd like to take the time in this lecture to speak in a bit more detail about universal grammar and why we might want to assume something like that might exist. Full disclosure, I'm a syntactician myself and I work in this area, and I would also consider myself a Chomskyan generative syntactician. So my leanings are very much toward universal grammar. So let's start off with a question. Is the following grammatical? Alternatively, we could ask, is it English? 'Twas brillig in the slithy toves, did gyre and gimble in the wabe. All mimsy were the borogroves, and the momraths outgrabe. This is an extract from the Jabberwocky by Lewis Carroll. You might already be familiar with it. We might not understand exactly what it means, but we do have a sense of what it might mean, and it does seem to be English, although the words are words that we might not understand or might not be familiar with. So, for example, even if the words don't have meanings that we might be familiar with, we would still know the kinds of meanings that they might have. For instance, a tove seems to be a noun, and there are more than one of them, because they are toves. The toves have a slithy or a slithy characteristic to them. Slithy then seems to be an adjective. And a wabe is a location that has a spatial dimension. So what is grammar? Well, the grammar we might be familiar with is what we would call prescriptive grammar. These are a list of do's and don'ts, something like the 10 commandments of language. For example, don't use the word ain't, don't start a sentence with a conjunction, don't strand a preposition at the end of a sentence, etc. The problem with these kinds of rules is that they're not very systematic. They just seem to be a list, and an unending list at that. It's very difficult to learn all of them. In fact, I would argue that prescriptive rules don't tell us much about language. They tell us a lot, though, about the people who invented them and the people who enforce them. Here's an interesting thought experiment. If I were to give you a prescriptive grammar of a language, say, Klingon, and let's say that that list looked a little bit like the ones on the screen, would you be able to speak Klingon using that grammar? The answer is almost certainly no. During this course, we've argued for rules of the following type. S breaks into a noun phrase and verb phrase breaks into a verb and noun phrase, etc. These are rules that we would call generative. This is because with these rules, we are able to generate all and only the grammatical sentence of the language. So it's less like a list of 10 commandments of do's and don'ts, and more like a recipe to bake a cake. Of course, this view of grammar that we have been arguing for was not always so obvious. What we're going to do now is look at 3 conceptions of grammar: behavioristic and connectionist views of grammar, an anthropological relativistic view of grammar, and Chomsky's generative view of grammar. Behaviorism, simply put, is the idea that we learn from everything we know from our environment through a process of stimulus and response. So, for instance, if you do something, you will get either rewarded for it or punished for it, and that will give you an idea of how to act in future. Behaviorism was very prominent in the 1940s and 1950s, and a particularly significant book called Verbal Behavior was written in 1957 by an academic called Skinner. Skinner, by the way, had some really odd views and was rather an eccentric character. He used to sleep inside a bed that was placed inside a special spacesuit-like capsule. Skinner argued in this book that behaviorism could be applied to learning language, and that children learned language through behaviorist principles. The rewards that Skinner was thinking about were either direct rewards, where someone would say, yes, that is correct, or an implied reward where the environment changed. So, for instance, if a child asks for a glass of milk, and the parent opens the fridge and gives them a glass of milk, then that would count as a reward. And the idea was that language could be learned this way. One of the central ideas behind behaviorism is that the mind is a black box. By a black box, we mean it's something that we cannot see inside. All that we can observe is external behavior. So in this view of language, there is no grammar. Whatever happens in the mind stays in the mind, and there's nothing we can really say about it. In 1959, a relatively unknown academic called Noam Chomsky wrote a very scathing review that completely demolished Skinner's behaviorism in cognitive, psychological, and linguistic circles. According to Frederick Neumayer, Chomsky's review has come to be regarded as one of the foundational documents of the discipline of cognitive psychology, and even after the passage of 25 years, it is considered the most important refutation of behaviorism. Nowadays, the idea of the mind as a black box has largely been put aside. This is because increasingly we are able to look inside the mind using psychological techniques and inside the brain using MRI, fMRI, and other technology. Behaviorism has developed a more recent instantiation in the guise of something called connectionism. Connectionism is a computer technology relying on Markov models, also called neural networks, which emulate learning and artificial intelligence. According to connectionists, we can indeed see inside the black box of the mind, or at least of the computer's mind, and what we would see there are a lot of connections between neurons and synapses, each one with a mathematical weighting. The problem with it is that this is a representation that is not really amenable to human understanding. So once a neural network has learned something, it is very difficult to look at the connections inside and to infer a scientific generalization from it. Let's move on to an anthropological and relativistic view of language. According to this view, there is no such thing as universal grammar. All languages are entirely unique cultural products that are related to the culture of the people who speak them. That means that language structure is also culturally specific, and there are no necessary commonalities between languages. Language, then, is an abstract concept that is a social invention. People will use individual languages in their own cultural ways. Accordingly, languages should be understood in their own terms. There are no universals, and there can be no universal grammar. This view of language sees the human use of language as just a natural extension of communication systems in the natural world, and there is no principal distinction between communication and language. That is something that we've argued against in this course. Thus, language gives insight into the culture that produced it. As a case study, let's look at Dan Everett's research on the Biraha tribe of the Amazonian basin. This group of people are incredibly isolated in dense rainforests, and their language has a number of interesting characteristics. For instance, there are only 3 pronouns. They have a number system that consists of 1 and more than 1. So Biraha people have trouble counting to 3. That is not even possible in their language. There is no future tense, and there is no past tense. Very significantly, there is no embedding. What that means is that there can be no recursion. Examples of embedding are things like, I know that he said that, or Sandra's parents' friends' children. This has been covered in previous lectures. Now, it's all very well that languages have different forms and structures. That is not really unusual. However, Dan Everett took another step. By saying that language is created by culture, he was saying that the particular structures of the Biraha language did not come from the fact that we all have the same human brain or the fact that we all have the same language faculty, but rather that they were different because the culture was different. He claimed that the Biraha live for the here and now. They don't think about the future and they don't think about the past. And for this reason, their language has no need for future or past tenses. In fact, the Biraha have no stories of any kind. They have no creation myth. All they say is, oh, it was always like this. Similarly, because they live in a communal culture where there are few individual possessions, there is no need to count to more than 1. Perhaps most controversially is the implication of the apparent absence of recursion in Biraha. Dan Everett claims that the Biraha are incapable of complex thought because complex thought relies on recursion. For instance, if you were to say something like, if I have a red nose and a painted face and funny shoes, then I must be a clown. That construction relies on recursion. So Dan Everett claimed that because of the culture of Biraha prevents them from having complex thoughts, that is the reason why there would be no embedding in their language. There are a number of problems with this. The first is a philosophical one, and that is that it has long been held that there is one human species with one set of human brain functions, and that humans everywhere are intellectually equal. Everett's claim comes very close to the now discredited idea that primitive cultures have primitive languages. Nowadays, the very notion of primitivity, primitive languages, and primitive cultures has been thoroughly discredited. Modern linguistics research shows that there are no primitive languages. All languages are incredibly complex and are essentially equal in terms of their complexity, no matter where in the world they come from or which culture they come from. Dan Everett would claim that the Piraha are the sole exception. There are also some other problems with this view. When Everett first went to the Piraha and studied their language, he analyzed it in a particular way that did say that they had embedded clauses and embedding. It was only much later that he changed his mind about this. Nevertheless, his work has been reviewed by linguists who have indeed discovered that there seems to be a relative absence of embedding in the language. However, other linguists have pointed out that it is not that there is no embedding at all in the language, but that embedding takes a particular type, therefore that there is recursion. In addition, there have been psychological tests conducted on the Piraha as a result of these kinds of claims, which shows that the Piraha are perfectly able of undertaking complex thought. Needless to say, this anthropological and relativistic view would claim that each language must be viewed on its own terms and there can be no universal grammar. Personally, I'm not very enamored of this view. So far in this lecture, we've looked at a number of conceptions about what grammar could be. We considered prescriptive grammar. Then we explored the behaviorist view of grammar as a set of stimulus-response behavior patterns, and this is closely linked to the connectionist view of grammar as a set of connections between different computational nodes. We also looked at the anthropological view of grammar, and now we're going to have a look at a generative linguistic view of grammar. Noam Chomsky wrote Syntactic Structures in 1957 and developed a generative grammar, which we also call transformational grammar. A generative grammar is a device in the mind or on a computer or even just an algorithm that you can work out on paper, which produces all and only the sentences of the language. The goal of syntax is to build a generative grammar of a language that uses a finite set of abstract rules, which can then be applied to all other human languages, and ultimately explain not only the language in question, but why all human languages are the way that they are, and to bring a unity to the concept of different languages under one human language. Chomsky held that language is so complex and the conditions under which they are acquired by children are so chaotic that language is not actually learnable without some innate assistance. By innate we mean something that's in your brain, something that is born inside of you. Chomsky then proposed universal grammar as this innate assistance. Universal grammar is a born-in language acquisition system that provides the basic tools of language along with some settings. These are a bit like the Preferences tab in your computer software. As children are exposed to language in the environment, usually in their families or among their peers, they gradually adjust the settings of their internal grammar until they are able to produce the language in question. Under this view, language is acquired by exposure to a linguistic environment and through a process of internal setting of mental parameters that ultimately come from universal grammar. There's been quite a bit of debate about exactly what universal grammar consists of, and when we do syntax in second and third year, we will become much more specific about exactly what universal grammar might be. For now, it's sufficient to say that universal grammar consists of three operations: merge, move, and agree, which you have encountered in previous lectures, as well as a set of features such as person, number, etc., and a list of parameters. These are the settings that can be set one way or another for a particular language. One kind of parameter, for instance, might be WH movement. In languages like English, this is set to move question words to the front of the sentence. In a language like Bulgarian, it is not only one question word that must move to the front, but every question word that must move to the front. In contrast, in languages like Chinese and Isixhosa, question words remain in situ. That is to say, they remain in their original positions in the sentence without moving to the front of the sentence. In the next part of the lecture, I'd like to consider a number of arguments for why universal grammar might exist. I'm not trying to be comprehensive, and there are a lot of details that will have to be left out, but you're also welcome to explore these in your own time. One kind of argument in favor of universal grammar is because there exist interesting similarities between languages. Now, of course, we expect languages to be similar when they're related or when there's been contact and borrowing between languages. But what about situations where languages developed independently of each other and yet end up with similar features? Now, there are many of these kinds of features. I'm just going to focus on one on this particular slide, namely double negation. So if you want to express negation in French, what you do is sandwich the verb between two negative particles, ne as a prefix and pas as a suffix. This would get you something like je ne mange pas beaucoup, which means I do not eat very much. Interestingly enough, isiXhosa also has a double negation. In the sentence andifuni ukusebenza, the a prefix indicates negation and the e suffix indicates negation as well. So in a way it is similar to French because the verb is sandwiched between two negative particles. We can see a similar process at work in Afrikaans. Ek wil nie swem nie. Here again the verb is sandwiched between the first nie and the second nie. Well, finally, what about English? In English you would say something like, I don't have any. So surely that would be a counterexample. Well, yes and no. First of all, note that in many English dialects, the any would be replaced by negative. For instance, I don't have none. In this instance, there's a negation, don't, before the verb, and another negation word, none, after it. So it would appear the verb is sandwiched between two negations. But let's look at I don't have any again. What's actually going on there? You'll notice that if you take away the first negation, then the sentence becomes ungrammatical. I don't have any versus I have any. So it would look as if the second any is somehow dependent on the first negation. So one possible analysis would be to say that any is a kind of a negative particle. We might call this a negative polarity item. If we analyze any as a negative particle in this way, then it would seem then English does show the sandwich pattern. There are many examples like this of languages that have curious and oddly specific similarities even though there's no contact or no genetic relationship between those languages. The question to ask is, if language is just like culture, and like culture is infinitely variable, what are the chances of there being any generalizations at all? Clearly there seems that there is some limitation to the kind of variation that can occur between languages. And where does this limitation come from? Well, one answer is that it comes from the fact that we have the same brain, and that we have the same language faculty, and that we have the same universal grammar. Some of the longest standing and most traditional arguments for universal grammar come from the area of language acquisition by small children. Chomsky argued that language acquisition contexts were characterized by something called the poverty of the stimulus. What he meant by that was that real language, when you listen to it, is very chopped up, lots of incomplete sentences, there's a lot of ungrammaticality, there's a lot of stops and starts, and not all kinds of constructions are equally well represented. Anyone who's been in a home with a small child will know there are a lot of orders, do this, do that, a lot of telling no, but on the other hand, relatively few subjunctives. So Chomsky argued that there was not enough data in the child's world with which to acquire the richness of human language. The poverty of the stimulus argument was often combined with the critical age hypothesis. This refers to the notion that children can only acquire natural language before a cut-off date, usually coinciding with around puberty. Evidence for the critical age hypothesis comes from, amongst others, children who have been abused or deprived of contact with human language. There are a number of such cases, for example, Jeannie and Isabel, whom you've heard about in other modules. Interestingly enough, children who had been deprived of language but were rescued while they were still relatively young managed to acquire language fairly quickly and effortlessly and catch up with their peers, whereas children that were rescued after puberty found it much harder and in some cases never developed language. The critical age hypothesis seems to indicate that there's a biological basis for language. In other words, language is not purely cultural. From this, it is a relatively short step to say the biological basis of language surely includes some type of universal grammar. Over the years, there have been a number of criticisms of this approach. For instance, it has been demonstrated that there are a wide variety of linguistic constructions used at homes, that children are exposed to lots of different types of language, and that given this, perhaps the poverty of the stimulus is a little overstated. Personally, I prefer another kind of argument that comes from language acquisition context. I'm going to call it the richness of the stimulus. If you leave a recorder in a room in a home and then come back an hour later to listen to the kinds of sounds on it, you'll find that it is incredibly rich. There are telephones ringing, there are adverts on the TV, there's a sound of lawnmowers, the neighbors might be having a shouting match, cars drive past outside, alarms go off in the neighborhood, some people are talking. Behind the people talking, there's often a TV or a radio playing music. In fact, the ambient context of a typical home is characterized by extremely rich auditory stimuli. In this context, one might expect that a language learner would find it difficult to know which sounds are meaningful and which aren't. A purely behavioristic learner, such as a parrot, might be expected to acquire a whole lot of sounds that aren't linguistic sounds. For instance, a parrot might acquire the sound of the telephone ringing, whereas as far as I know, no child has ever acquired the sound of the telephone and mistaken it for language. So how would children know which sounds are language-like and which sounds are just sounds? It seems to me that universal grammar in the mind could be useful in forming a predisposition to work out a priori which sounds are relevant and which sounds are not. Another argument for universal grammar comes from early studies of the brain. It was discovered that there were two parts of the brain that were useful for language, one called Wernicke's area and one called Broca's area. Wernicke's area was linked to meaning and concept formation, while Broca's area was linked to motor control and phonology. Hospital patients who had damage to either of these areas developed different kinds of symptoms called aphasia. So it was a natural thought for many people to think that since areas of the brain seemed to deal with language, that perhaps there was a biological basis to language after all. And if there's a biological basis, the argument for universal grammar becomes much stronger. More recently, however, it's been found that this research perhaps overstated the case. Research has shown that these areas are also used for other things, and that a wide variety of brain areas are used to produce language. So it is far from the case that there is a single part of the brain that produces language. So language may be modular from the perspective of mind, but apparently not from the perspective of the brain. So it turns out that these arguments are perhaps not as strong as we originally thought they might be. Another type of argument comes from language creation. For example, when people from two different languages or cultures come together, perhaps to trade, they might develop something called a pidgin. A pidgin is a limited kind of language, often omitting a lot of nuance and including just a few words, and it is quite similar to what we might think of as foreigner speak. What is really interesting, though, is when pidgin speakers have children, their children create rules where there were none before. In the process, the pidgin turns into a language with all the complexity of any other natural language. We call these created languages creoles. Now, if language were purely cultural, we would expect children to acquire the pidgin more or less intact. However, what seems to be the case is that children take the pidgin and modify it to create a nuanced natural language from it. What motivates this? So one answer might be is that although the pidgin language is in the social context where children are learning language, children are actually drawing on universal grammar in order to actively construct the language in their own minds. Another example of this kind of phenomenon comes from Nicaraguan Sign Language. In Nicaragua, there was no sign language. Children who were born deaf didn't learn any sign language at all. Their families just made do. And at some point, a lot of these children were sent to a particular school. So at the school, you had a lot of children who were not able to speak orally, who had not been trained in any kind of sign language, and had very little way of communicating with each other. The miraculous thing that happened over time, however, was that the children invented a sign language that had all the characteristics of other human languages, and in fact has a lot of similarity to other sign languages around the world. The spontaneous creation of language in this fashion suggests that language is not purely a social phenomenon, but must have some kind of biological basis. We could ask ourselves, what motivated Nicaraguan deaf learners to spontaneously and unselfconsciously create a language? The answer might be something like universal grammar. Another very interesting argument for universal grammar comes from the case of a linguistic savant called Christopher. Christopher is severely mentally disabled. He needs permanent care. He's not able to do any kind of mathematics. He cannot do his own shopping, and he cannot tie his own shoelaces. But from a linguistic perspective, Christopher is an absolute genius. He speaks something like 16 different languages and can acquire them really quickly. In fact, he learned Dutch for an interview in just 2 weeks using a dictionary and the newspaper. So Christopher is an interesting case because his language faculty is really well developed, but his general intelligence is not particularly strong. Incidentally, this shows that language ability is not linked to general intelligence. Christopher has been a part of a number of experiments, mostly conducted by Professor Neil Smith from University College London. In one set of experiments, the researchers took a group of university students who are highly intelligent and set them a simple linguistic puzzle. They gave the same puzzle to Christopher. The puzzle consisted of having to learn an invented language, but which included one rule which we know that no natural language has. In other words, this was a rule or a pattern that could be inferred using general intelligence, but had no linguistic basis. The researchers expected that, in fact, the highly intelligent university students would be able to solve the puzzle easily, whereas Christopher would struggle. In fact, the findings were even more interesting than that. Neither the university students nor Christopher were able to solve the puzzle. What this suggested is that the patterns that we might find in language are quite different to other kinds of patterns that we might find in the world. In other words, languages do not vary infinitely, but there are definite limits to the kinds of structures and the kinds of patterns that we find in language. Again, this would be unexpected if language was simply a matter of learning behaviors in a behavioristic way or in a cultural way. We could ask ourselves, where does this restriction on the possible patterns in language come from? And the argument might be universal grammar. Another reason that we might want to draw on universal grammar is because it makes good scientific sense to develop generalizations and to use those generalizations to explain other phenomena. Generative grammar has been extraordinarily powerful and successful. So even if you don't particularly subscribe to the notion of universal grammar, having a useful set of tools to understand and explain the structure of the world's languages is useful in its own right. Ultimately, even if universal grammar were disproved tomorrow, the theory would still remain useful. So what do we mean when we say that even if universal grammar isn't real, it would still be useful? There are many examples of this kind of thing happening in the history of science. For example, when Isaac Newton developed the equations for determining the positions of planets, the question we could ask is, are those equations real or merely useful? At one level, you could say, well, the equations are just mathematical abstractions. They're not real in the sense that they don't exist in the real world. However, many scientists would probably disagree and say that the equations are, in some deep sense, real. Another example starts in the 19th century with studies on electromagnetism, a rather curious force and very misunderstood at that time. Maxwell developed a set of mathematical equations to explain electromagnetism, but he himself didn't think that they were real, but merely some useful equations that helped get the facts right. It was fact only in the 1920s, about 60 years later, with the advent of quantum theory, that Maxwell's equations were shown to be not only useful, but actually part of the real world. Last example, in particle physics, there were a number of difficult phenomena that could only be explained by the invention of a small particle called quarks. They came in different flavors, quarks called up, down, strange charm, bottom, and top. For many years, physicists thought that these were just useful inventions to help explain the phenomena, that they weren't actually real. But as time has passed, more complex detectors have been created. It has been demonstrated that, indeed, quarks are real. So even if we don't believe in universal grammar, and see it just as a useful set of rules of thumb, there's a very strong tendency for scientists to start to see their generalizations as being real. Consequently, time will tell if universal grammar is truly real or just a useful set of theoretical abstractions.